Let's talk about creating a drawing for lesson 7, number 3. I'll open up a new drawing and let's try wizard. So I'm going to pick this part off the tree first so it knows I just want to see this piece. I'll just use that as a front view. I should have picked that front face, but alright. The only view I really want to talk about dimensioning is this one. You should know how to dimension the rest. I don't want to do the whole thing for you. The size of this part may vary from the book. You're supposed to dimension it per the book, not per my video. This is an example, not the answers, but I'm probably pretty close. Alright, so we'll go to annotation. I'll turn my tree on so I can make sure I'm in the front view. And let's do some stack dimensioning. A dimension from here to here. I always do the overall first and then work my way through. So stack dimensioning is really cool, really easy to work with. I need my center marks on here, so let's go to properties. Can't remember which one does what. What I do is I just click on it's either axis or center line. I hit apply. If it doesn't show up, I'll turn axis off, turn center line on, and hit apply. Now I see my center lines, my crosshairs. Let's go ahead and turn off the grid for now. And we'll go back. Stack dimension. And we'll dimension to the holes. Whoops, I missed this one. What's cool about stack dimension is it'll add in anything I miss. Alright, let's just highlight these and go to our property. Shoot. I didn't mean to cut. I meant to go to properties, value, and we'll numdink this. Okay. So stack dimension works great, but you have to think about your dimensions. So a couple issues here. It's really not a good practice to dimension to here because I'm dimensioning to a T right here. Again, we're dimensioning to a T right here, so that's not really good. Here's another thing. This notch from here to here, according to my math, 4 minus 1.5 comes out to 2.5. So I want this to be from here to here at 2.5. Okay, the part that fits inside this piece here, if I measure this item, this is going to be 2.5. Let's try this again. Measure item. I'm going to try and grab that edge. This cursor I have, sometimes it's tricky to get that edge. I'm trying to get this white line right here. It's grabbing that whole face. You see it's trying to grab that whole face there. Let's try this. Measure between. I'll measure between the two faces here. That is 2.5 as well. Okay, so if this piece here is 2.5, and that's 2.5, I'm already not even going to get that to work. It's going to lock in. But let's go beyond that. I'll talk about tolerance later. If this is an ANSI drawing and my engineering tolerance is plus or minus 30 thou, that means this number here could be 1.53 and still be within engineering tolerance. This number here could be 3.97. If this number were 397 and this number were 1.53, the distance from here to here is actually going to be 2.44. So if this is 2.44 and then this part here is 2.5, it's really not going to fit. So first off, best way to dimension to try and hold that thickness to 2.5 would be to remove this one. Wait a minute, let me just put this in first. I want to control the distance from here. From here to here. We want to chain that dimension. We'll numpdate that. So I really want that to hold 2.5 inches. So this 4-inch dimension, if I leave that in there, I'm over constraining this. I'm double dimensioning. So I need to delete that one dimension. Now I just ungrouped it, so I lost my links to this being stacked. Okay? So I shouldn't have done that, but what I do want to show you is this dimension here is now controlling this. So the worst case scenario, it would go down to 247. Whereas before, the other way I dimensioned it, the smallest it could be is 2.44. Again, that has to do everything with engineering tolerance. If we were using plus or minus 30 thou, that's 0.030, 30 thousandths of an inch, then this dimension will go to this, the minimum number would be 247 and the maximum number would be 253. And then when I go to dimension the other part, I want to control that as well. Alright, so in reality I'd want to oversize this a bit and undersize the other one, and that can be controlled in the dimensioning. So we'll talk more about that. Now also just as critical here is I need a dimension from this hole to this hole, because this number here is 0.73 and this number here is 4.78. I'm still within engineering tolerance according to how I dimension this. Well, that's going to be a problem when I go and try and line up these holes to these two pins sticking out. Now think of it this way. If they dimension this drawing for this part the same way I'm doing it, technically speaking, on the other part, instead of this one being 7.3, it could be 7.8. And then instead of this one being 4.78, this could be 4.73, which would mean that the pins and the holes would be over 1/10 of an inch off from each other, and they really would not fit. So again, I want to delete just that one. I'm forgetting how I did that. Geez, how did I delete that? I'm just gonna ungroup that for right now and delete this. And what I really want is not this dimension either. I don't want to come from the edge. Okay, I'm going to put that back for a sec. Now some of you are thinking, wait a minute. You put this axis, which means this is our datums, on this corner over here. So if this is datum A, and this is datum B, your instructions prior to this may be, hey, I've always thought we try and dimension from the datums. Yes, that is true. This 2.75 is coming from the datum. So I can remove this dimension, and some might think, well, we could chain this dimension from here to here. I should have grabbed that one first. I could chain this dimension from here to here and to this center line. And let me just undink that. Alright, so now I'm holding it symmetrical. Let's think about this though. What's engineering tolerance? This engineering tolerance says that this could be 2.03 and this could be 2.03, which means the distance between these two pins is not going to be 2.03 or 4.0. It's going to be 4.06. Okay, so again, if I want the distance from this hole to this hole to be 4 inches, I need to dimension from hole to hole. This here, dimensioning, again, this could be 2.03, 2.03, and it would be 406 apart, or it could be 1.97, 1.97, meaning it would be 3.94 inches apart. So either way, I could be off a total of 60 thousandths of an inch. Now, what if I dimensioned it this way and the shop made it 203 and 203? It's still within engineering tolerance. And then on the drawing, for this part, they dimension from here to the center and then from the center to here, and they change dimension as well at 2 and 2. But the other shop builds it at 197, 197. That would mean that the distance from this pin to this pin would be 3.96. And back to the drawing, if they had made this part at 203, 203, you're looking at 4.06. So now again, you're off by 0.12 or 120 thousandths of an inch between your pins and your holes. That's why we want to remove this dimension here. Okay, I want to remove this dimension here so that from here to here is 2 inches, but from here, from this pin to this pin, it's going to be 4 inches. All right, that's going to give me a lot better shot if both are dimensioned the same way. You're going to have a lot better chance of getting that to work out. Now I'm also going to show a different way to handle that. Okay, but for now, this is how I want you to dimension it. I want you to try and control the holes. Think about how the holes have to line up. Also, another thing you might want to do is intuitively you've been taught to dimension from the datums. So if I give this dimension though, from this bottom up, and I'm off, and then I do the same thing for this one, from the bottom up to these, if I'm 0.3 too tall here, and 0.3 too small on this one, it's going to be that much further off. So I don't want this dimension. What I would do is I would dimension from the top of this line to this center line over here. And you might have to zoom up so you can grab that center line that you want to get. And you want to dimension it this way. That way on both of them you're dimensioning it from this center to here. And I'm trying to make these holes and pins all line up with each other. That's why I'm so focused on dimensioning these 3 dimensions. Those ones there are all what's going to control how they link up to each other from one part to the next. These are the things you got to think about. Yes, these are my datums. This is how they're going to build the part. But the issue is I am dimensioning from the datum to the center. That's what this dimension here is going to control. Okay. And I'm not going to dimension this one. I can't dimension to this one, so that's got to go. All right. I want to dimension a stack dimension from here to here to that center line. Up. Oh, I missed. Stack dimension from here to here. Sometimes this thing is a pain. I have my cursor set up so it's easy for people to see my cursor, but it's hard for me to work with. Okay, I'm going to move this down here. And we'll numdink that. I'm getting rid of this one because it's not stacked. Problem is I got this one in my way now. No matter where I try and move this, it's kind of a pain. Okay, so what I'll do is I'll delete that. Up in this view, we will change our graphics to show the axis for the hole. And it gives me the center line. What? So we're going to generate the axis. We should have hidden lines on there. I don't need fillets. Okay. So now what I'm going to do is stack dimension. For this outside here to this one here. Put that up there. Normally I wouldn't dimension this width there. I'd like to dimension it down here, but I'd get rid of them on this view. I don't need it here. I don't need it here. Okay, just because I know it's going to be cleaner and easier for me to visualize, and I want to demonstrate I'm going from the center out and then from here to here. That's how I hold a symmetrical part. We no longer, since 100 years ago, can call this a center line and say dimension symmetrical. It doesn't. They don't do that. That's not a thing anymore. Okay, so ANSI ASME specs to hold symmetry. You have to hold symmetry, these holes and these holes, to be symmetrical by dimensioning from the center out and then from the pin to pin or hole to hole. To hold this notch, a dimension from the center to here and then from here to here. That controls that. Okay, and then again up here I'm controlling symmetrical this way. This dimension here, going from here to here to here, this is not symmetrical. There's nothing symmetrical going on. So I would dimension from the datum and stack dimension. But this one I'm going from the center over and over, okay? So yes, even though these might be your datums, it's not wrong to dimension from these centers. In fact, that's how you got to do it to hold symmetry. This dimension's not good either. Somehow I got to get dimension to this thickness, but the problem is here, you can't dimension to this T, all right? And over here, I really can't see that. And then up here in the top view, really can't tell what's going on because you would have to be dimensioning to a hidden line, and you're not allowed to dimension to a hidden line either. So how can I get around this? One thing I could do is put on a dimension from here to here and move this out and select that that triangle, and I could type in THK. What that would tell the shop is that this is a constant thickness throughout there. Okay, I didn't fully dimension that. That's up to you guys, but a lot of people get confused about why I dimension it like this. Why don't I dimension everything off the datum? And the reason is because I'm not holding the tolerance the way I want to hold it if I don't dimension off the center. So again, when you create symmetrical parts, this is your better technique. Hopefully you can use this as an example on how to go ahead and finish the two drawings for these two details.